Suppose that a test for a disease correctly gives positive results from 95% of those having the disease and correctly gives negative results for 90% of those who don't have the disease. Suppose also that the incidence of the disease is 1%. If a person tests positive for the disease, what is the chance that they have the disease? Find the exact percentage. In order to solve this particular problem, we're going to have to be working with some assumptions. One of the things that we can do is pick a number for the size of the group that we're going to be looking at. For example, we could pick a group, let's say size 10,000. And we know that the incidence of the disease is 1%. So in this particular case, when I say that the incidence of the disease is 1%, is we're going to look at this and say, okay, that right there is going to need to be multiplied by 10,000 so that I know how many people will have the disease, and then we can discuss how many will actually get a positive result and how many will actually get a negative result. So we realize that we're going to assume 10,000 people with an incident rate of 1%. And that yields 10,000 times 0.01, which is 1% as a decimal. And that's going to yield the fact that there are 100 people in this population that will have the disease that we're looking at. So if that means that 100 people have the disease, then 9,900 people will not have the disease. If this is the case, then we want to start looking at percentages of the number of people who have the disease and then the number of people who do not have the disease. And what we're going to do is we're going to use a table. And we're going to go ahead and create this table. And this particular table is going to have 3 columns and 3 rows. And one column will be for the disease, and then the second column will be no disease, and then obviously the third column will be total. Our first row will represent when the test is positive, the second row represents when the test is negative, and then the third row once again is going to be the total. So now, as I said, we're going to have to look at this and we understand that the test for a disease correctly gives positive results from 95%. Which means that we're going to go ahead and find 95% of the 100 that we know will have a disease. So that becomes our first step. Or actually, I'm sorry, that becomes our second step. Because we've already calculated that there's going to be 100 people that will have the disease. So the test is 95% accurate. And that means that we're going to take 0.95 and we're going to multiply it by 100. And that will give us 95. That's going to be our first value. And that 95 is going to go into our table right here. Well, if there's 100 people total, okay, that means that there will be 5 that go right here where they have the disease, but the test gives a negative. And so now we have our total of 100 people. Now we also have to look at the fact that there are going to be a number of people who don't have the disease. And as we've already calculated, we know that 9,900 of them, and let's scroll back up and I'll show you that right here, 9,900 people will not have the disease. So that's going to go right here in my total column. And that means that I have to figure out how many people who do not have the disease will have the correct test that will diagnose them correctly, and how many people do not have the disease and they won't be correctly diagnosed. And we know that the rate, as we go back up to the original problem, is going to be set up as correctly gives negative results for 90% of those who don't have the disease. So we know that we have 9,900 people that do not have the disease. So we know that we're going to go ahead and look at the fact that for our next step, that we take that 9,900 people and we're going to go ahead and consider that the test is 90% accurate, which means that we're going to multiply 0.90 times 9,900, and that will give us 8,910. This particular value is going to go right here, because it is 90% accurate in determining that the person does not have the disease. Which means that we're going to go ahead for this part right here where I'm putting the asterisk, we're going to need to do step number 4, and that's simply going to be to take 9,900, which is the total number of people who do not have the disease, and we're going to subtract from that the 8,910 people that we know do not have the disease and were tested correctly, and that's going to yield a new value of 990. And this 990 is going to go right up in here. Now what I want to do is add my columns across. So we need to add, and I'm sorry, I said columns, and it should be add the rows. So add the entries in the rows. And this right here, the 95 plus 990 is going to give me 1,085. And then I'm going to have 5 plus 8,910, and that's 8,915. And then if I add 109,900, I will get the original 10,000 that I assumed to be my sample size. Now, to find out what the percentage is, and remember what the problem is asking for, it says if a person tests positive for the disease, what is the chance that they have the disease? Find the exact percentage. Right? If the person tests positive for the disease, that's going to be right here in this particular box. And that's going to be divided by this total amount here. So in order to answer the question, step number 5, we're simply going to take 95, and we're going to go ahead and divide that by 1,085. And we will get a decimal number for that, and it will be equal to 0.08755, and it is a non-terminating, non-repeating decimal, and it goes on, and so we will round that to approximately 0.88. Now, to get the percentage as the problem wanted, we're going to have to multiply this by 100. So we take the 0.88 and we multiply that by 100. I'm sorry, that's 0.088. I apologize for that. And that's going to give me 8.8%. And that is going to be the answer for the problem. So, as I said, 8.8% is the chance that they have the disease. And that's how we do this particular problem.